Hello everyone. Let us see the topic series compensation. In power system, compensation is required for maintaining the voltage at a desired level. If compensation is not done, then due to change in the load conditions, that is the change in load conditions, that control of the load is not in your hand. So the loads are continuously changing, and due to change in the load conditions, the requirement of the reactive power on the load side is continuously changing, and due to change in that reactive power there will be change in the voltage. So due to change in the voltage, there may be effect on the equipments, that is equipments which are connected on the load side. They are designed with the specific voltage, they are designed with the rating of a specific voltage and specific frequency, and if the voltage is not proper or within their limits, then that equipments will damage. So compensation plays a important role, or we can say vital role, in maintaining the voltage at the desired value. So whenever there is a requirement of the reactive power on the load side, this reactive power will be given by the additional devices like capacitors, synchronous generators or synchronous machines, or if there is excess amount of reactive power, that excess amount of reactive power is absorbed by the reactors, by the synchronous machines. So absorption or supply of the reactive power as per the requirement of the load is called as a compensation. For compensation, we are using the devices like reactors, capacitors, synchronous machines, or any combination of these three. So there are two types of compensations. We can call as series compensation and shunt compensation according to the connections of these devices. Let us see the series compensation. So series compensation is another powerful tool to improve the performance of a EHV line. So with the help of this compensation, we can improve the performance of the EHV line, extra high voltage lines. So what it consists of? It consists of capacitors connected in series with the line at suitable locations. It consists of capacitors connected in series with the line at suitable locations. So what are the advantages of series compensation? The use of the series compensation leads to number of advantages as regards power system capability and voltage regulation. So increase in the transmission capacity. The first advantage of series compensation is increase in the transmission capacity. How the transmission capacity increases, let us see. So the power transfer equation is given by P equal to V into R divided by X into sin delta. This is a general equation of transfer of the electrical power. So if we are considering that series compensation is not there, means the capacitors are not connected in the circuit, that time the power transfer equation is given by, let us say that power will be the P1 equal to magnitude of Vs into magnitude of Vr divided by XL into sin delta. What is Vs? Vs is the sending in voltage. So Vs at an angle delta is the sending in voltage. Here we are taking only the magnitude of voltage, that is mod Vs. Vr is the receiving in voltage. So Vr, the reference voltage is always in power system. The reference voltage at the receiving end is always considered as a 0 degree. So Vr at an angle 0. XL is the inductive reactance of the line, and delta is the phase angle between Vs and Vr. So P1 is given by Vs into Vr divided by XL into sin delta, and this is the power transfer equations without any compensation. That is, capacitors are not connected in series with the line. Now let us see the same equation. What will happen if I add a capacitance is series with the line? So if a series capacitor having a capacitance Xc is inserted in the circuit, inserted in series with the line, the net series reactance, that is series reactance, is going to decrease, and that series reactance becomes XL minus Xc, that is inductive reactance minus capacitive reactance, and the power transfer at this condition, that is when capacitor is inserted, let us say it is denoted by P2 and is given by P2 equal to magnitude of Vs into magnitude of Vr divided by XL minus Xc into sine delta. So if I compare previous equation and this equation, that is P1 and P2, P1 is the power transfer when capacitors is not connected in series with the line. P2 is the power when capacitor is inserted in this line. From these two equations, it is seen that the denominator of the second equation is lesser than the first equation. All remaining factors, that is Vs, Vr, delta, they are remaining same. That is sending in a voltage, receiving in a voltage, and delta, that is angle between Vs and Vr, remains the same. So this power transfer depends upon this denominator. So in this, denominator is lesser, and in the P1 equation denominator is greater. So definitely P2 will be greater than the P1. So we are seeing that there will be increase in the power transfer, and that increase in power transfer is given by, if I take the ratio power P2 divided by P1, so I will get it is XL divided by XL minus Xc. So if I take the XL as a common or divide XL throughout, so I will get, if I divide XL throughout, I will get 1 divided by 1 minus Xc divided by XL, or this Xc by XL is denoted by K, so it is 1 divided by 1 minus K. So the factor Xc divided by XL, this is called as a degree of compensation. Degree of compensation, that is this ratio, or K. Xc divided by XL is called as a degree of compensation, and studies on the transmission system have revealed that in the view of line cost, the effect of line operating in parallel, and the problems of system protection, the economic degree of compensation lies in the range of 40 degree to 70 degree. That is the value of K, or the value of a ratio of XL by Xc lies between 40% to 70%, that is 0.4 to 0.7. So another advantage of the series compensation is improvement in the system stability. How the system stability will be improved? We have the two equations, P1 equal to Vs by Vr divided by XL into sine delta. P2 is Vs Vr divided by XL minus Xc into sine delta. P1 is when compensation is not there, or the capacitors are not connected in the series with the circuit, and P2 is the power when the compensation is done, that is capacitors are connected in a parallel with the in series with the line inductance at suitable locations. So it is seen from same amount of power transfer and the same amount of Vs and Vr, we are saying that we have to transfer the same amount of power, though compensation is there, though compensation is not there, with the same value of Vs and Vr. The phase angle delta in case of series compensated lines is less than that of the uncompensated line, because here the denominator is having a greater value, here the denominator is having a lesser value. To make a constant power transfer, we have to change the delta. So in the second case, delta will be somewhat lesser than the delta in the first equation. Then and then only we can transfer the same amount of power. So the phase angle delta in case of series compensated line is less than that of the uncompensated line. So it is known that for lower angle delta means there will be a better system stability, that is you will get a larger area, or we will say more area for the system stability. Some other methods for system improvement system stability are also used. These include reducing the reactance of the generators and transformers, use of bundle conductors and increasing the number of circuits in parallel. Series compensations generally offers the most economic solution with respect to both steady state and transient stability. Another advantage of the series compensation is load division between the parallel circuit. So, how the load is divided in the parallel circuit with the help of series compensation. The reduction in the series reactance by series compensation makes it useful tool to balance the loading of the parallel circuits. When a system is to be strengthened by the addition of new line, or when one of the existing circuit is to be adjusted for parallel operation in order to achieve maximum power transfer and minimize loss, series compensation can be used to a great advantages. So when we have a two parallel lines and we have to do a load balance between the two parallel circuit, that time series compensation is very useful tool to balance these parallel lines.